Operating principle of RAM type of digital voltmeters with diagram. Digital voltmeter. A digital voltmeter DVM displays the value of AC or DC voltage being measured directly as discrete numerals in the decimal number system. Types of DVMs. The increasing popularity of DVMs has brought forth a wide number of types employing different circuits. The various types of DVMs in general use are RAM type DVM, integrating type DVM, potentiometer type DVM, successive approximation type DVM, and continuous balance type DVM. Now let's discuss one of its type RAM type digital voltmeter. What is RAM type digital voltmeter? RAM technique. The operating principle is to measure the time that a linear ramp takes to change the input level to the ground level or vice versa. This time period is measured with an electronic time interval counter, and the count is displayed as a number of digits on an indicating tube or display. Block diagram of RAM type DVM. As a test DC input is given to a attenuator where it is compared with the input comparator by sample rate and ramp generator. Then it is given to the gate where gate is provided with oscillator and GND comparator, and the gate output is given to the counter. RAM type digital voltmeter DVM working principle. The block diagram shows above is the RAM type DVM digital voltmeter. You can see there is a ramp generator. This is generating a waveform which is presenting a ramp. The heart of the circuit is a ramp generator, therefore it is called RAM type digital voltmeter DVM. The input which should be measured is given at the input voltage. This input is fed to ranging an attenuator circuit which will amplify the signal is small or attenuates the signal if it is large. This is given to an input comparator which will compare two signals and generates the output. One input to an input comparator is from the input voltage and another input is from the ramp. This input voltage and ramp signal and compared and output is given. If the ramp signal is more than the input voltage, there will be no output, but if the input voltage is greater than the ramp signal, then A is generated which will open the gate. Now when the gate gets open, clock oscillator will send clock pulses which counter by counters and displays on the screen. The ground comparator will compare the ramp signal and ground, and output is given. This output will stop the flow of pulses from clock oscillator to closing the gate. The sample rate multivibrator is used to reset ramp generator. The operating principle of ramp type digital voltmeter is to measure the time that a linear ramp voltage takes to charge from a level of input voltage to zero voltage or vice versa. This time interval is measured with an electronic time interval counter, and the count is displayed as the number of digits on electronic indicating tube of output readout of the voltmeter. The conversion of the voltage value of the time interval is shown in the below timing diagram. At the start of measurement, a ramp voltage is initiated. A negative going ramp is shown in the below figure, but a positive going ramp may also be used. The ramp voltage value is continuously compared with the voltage being measured, unknown voltage. At the instant the value of ramp voltage is equal to that of the unknown voltage, which is considered coincident circuit called an input comparator generates a pulse which opens the gate. Ramp voltage continues to decrease till it reaches ground level 0 voltage. At this instant another comparator called ground comparator generates a pulse and closes the gate. The time elapsed between the opening and closing of the gate is T, as indicated in the below timing diagram of ramp type digital voltmeter. During this time interval, pulses from the clock pulse generator pass through the gate and are counted and displayed. Timing diagram of ramp type DVM. The ramp may be positive or negative. In this case, a negative ramp has been selected. At the start of the measurement, a ramp voltage is initiated, counter is reset to 0, and sample rate multivibrator gives a pulse which initiates the ramp generator. The ramp voltage is continuously compared with the voltage that is being measured. At the instant these two voltages become equal and coincidence, circuit generates a pulse which opens the gates, i.e. the input comparator generates a start pulse. The ramp continues until the second comparator circuit senses that the ramp have reached zero value. The ground comparator compares the ramp with ground. When the ramp voltage equals 0 or reaches ground potential, the ground comparator generates a stop pulse. The output pulse from this comparator closes the gate. The time duration of the gate opening is proportional to the input voltage value. Advantages and disadvantages. The ramp technique circuit is easy to design and it is low cost. Also, the output pulse can be transmitted over a long faded line. However, the single ramp requires excellent characteristics regarding linearity of the ramp and time measurement. Large errors are possible when noise is superimposed on an input signal. Input filters are usually required with this type of converters. Thank you.